Hi guys, this screencast goes along with your reading for today and tomorrow, and it's using Table R. So if you have Table R handy, I would definitely get it out or use it in your review book. There's a Table R towards the end or online. So you really can't do anything without Table R. So it's really a matter of how well you can read Table R to see how you do the next couple of days in chemistry. So Table R is like, oh my gosh, there's so much information, but it's really about narrowing down what they're asking you for. So for example, what they give you here is a class of compounds, and there's a multitude of class of compounds. The halides we've already done, so we're not going to go over them today. But same idea. So the class of compound is not halides in this case. It could be alcohols, ethers, aldehydes, ketones, organic acids, esters, amines, and amides. So that's a lot, but again, Table R. So the functional group for an alcohol is an OH is attached to a carbon. An ether, you have an O right in the middle. An aldehyde, you have this functional group. Ketone, very similar. Organic acids, similar still, but a little different. Ester, amines have a nitrogen, and amides have a C double bond O and an H. So that's the functional group. The general formula is really just a duplicate of the functional group. It has this R thing. If you look at the bottom, it says R represents a bonded atom or group of atoms. R represents any hydrocarbon. So we know if we see a hydrocarbon and an oxygen, we're in organic chemistry somewhere. It's one of these classes. And then the other neat thing they give you with Table R is they give you examples. So if you can read the examples and cross-reference it, you're in good shape. So for example, if I say you have 1 propanol for the example, they give you the structure, well, the condensed structure. So hopefully prop, you can recognize that means 3 carbons. So in this case, there's 3 carbons. The 1 is always a location in organic chemistry. So that's the location of the functional group. So because it's a 1, we would count, in this case, right to left. So 1, 2, 3. So that first carbon is hanging on to the OH, and that's where the 1 comes from. The OL means it's an alcohol. So if it ends in an OL, that means whatever it is an alcohol, like ethanol, propanol, 2-butanol, and so forth. So let me just give you an example. If I was going to draw the structure of 2-butanol, I'm going to write out the structural formula, not the condensed. So again, they do the condensed formula here because they don't have a lot of room, right? So I would draw 4 carbons in a row for bute, right? Table P. And then on the second carbon, I would put an OH group. And then the rest would be hydrogens all around. So 2-butanol again is the location. And it's on the second carbon, and I put an OL at the end because it has an OH group. So that would be an alcohol. So that's an example. Okay, so other examples of organic classes of compounds would be, let me just go in order here. So let me give you another example of something that has an OH group. So another group, not to be confused with alcohols, is an organic acid. Let me just erase all of this here. Okay, so organic acids also have an OH. See that there? But they also have a C double bond O. So if it has a C double bond O and an OH, it is an organic acid. They give you the prop series, so 3 carbons in a row. So you have 3 carbons in a row, which would give you propane, right? But you end it with propanoic acid because it has this functional group always at the end. So with organic acids, this functional group is always on the end because it ends with an H here, C double bond O. So if you recall from our acids and bases unit, or maybe it's been a while ago, we have this Cu ending. So that's that C double bond OOH. So let me just give you an example. So say I draw something like C double bond OOH. Maybe you can try to name that on your own using Table P. That would be called ethanoic acid. Okay, and going back now to the double bonded C's with a O. So we have aldehydes, whoops, sorry, C double bond OH, and then we have ketones, which also have a C double bond O. So the only difference between an aldehyde and a ketone is the location. Aldehydes always have this C double bond OH on the end. So it's always on the end. So if that C double bond O with an H is on the end, it ends in al. Very close to all, right? But al. So this would be called propanal. So if I wrote something like, and I'm just gonna, let's stick with the 2 carbons. I'm gonna make it this way. It's still on the end, right guys? It doesn't matter which side it's on. That would be called ethanal. Ethanal, A-L. Okay, and then we have the ketones. The ketones have the C double bond O somewhere in the center of the chain. So if that C double bond O is in the middle somewhere, it's not on the end, you give it a number, right? So this would be called 2, because it's on the second carbon, is holding the functional group. And pent, because there's 5 carbons, and you end it with -one. So this would be called 2-pentanone. So say I moved the carbon to, or I'm sorry, the double bond to the middle, then I drew my hydrogens all around, right? Remember, no hydrogens here, because it's already got 4 bonds around that carbon. That would be called 3-pentanone. Okay, and let's see. Lastly, well, there's 2 more things I want to talk about. If you have a oxygen in the center somewhere, it breaks up the chain. There's another one here. There's an ester. See, it breaks up the chain. That it's either going to be an ether or an ester. So just drawing the structural formula of the example they give you, methyl ethyl ether, there's an oxygen breaking up the chain like that. That would be called methyl ethyl ether, and ethers end in ether, which is pretty easy. The oxygen's in the middle. Now esters are a little different because they also have a C double bond O in there. So the example they give you here is methyl propanoate. So I just drew the structure of that. But notice there's an oxygen breaking up the chain and a double bond O. And that's an ester. And then lastly is the nitrogen series. So if you have towards the bottom of table R, we have nitrogens. And that would be an amine. So like, for example, an amino acid has a nitrogen in it. Straight up amines, not amino acids, but amines make up amino acids. They smell like fish, so they're really stinky. So if you have a nitrogen, it's either going to be an amine or an amide. If you have a nitrogen all alone with an organic chain, it's going to be an amine. If you have a double bond O carbon with a nitrogen, it's going to be an amide. So we'll ease into this. I know it's a lot to take in, but again, having table R at your fingertips helps a lot. It's like a map. Have a great day.